So moving on to the next question, which is asked from the subject transducers in test series 11 for IN, is of 2 marks, and it is from the topic resistive transducers. It's a multiple choice question. So we'll go through the question. So a 100 ohm strain gauge. So strain gauge has a nominal resistance of 100 ohms. Is bonded to a low carbon steel bar which has been subjected to a tensile load. So the bar has a uniform cross-sectional area of the steel bar has a uniform cross-sectional area. So the area is given as 0.5 into 10 to the power minus 4 meter square, and having an Young's modulus of 200 giganewton per meter square. So when a load of 50 kilonewton produces a change of 1 ohm in the gauge resistance, so what is the gauge factor? We are asked to find what is the gauge factor of the strain gauge. So gauge factor is nothing but change in resistance by the original resistance divided by change in length by original length. So we know the change in delta R as 1 ohm and R is 100 ohms. So in order to compute gauge factor, we need to know the quantity change in length by original length. So we also know that original length is, so we don't know what is the original length. So from the question, so we need to compute the change in length by original length. So which we can calculate from the Young's modulus expression, which is nothing but stress by strain. So Young's modulus is given as 200 into 10 to the power of 9 Newton per meter square is equal to stress is nothing but force per unit area. The force is given as force on load, which is 50 kilonewton, 550 into 10 to the power of 3 divided by the area, cross-sectional area, which is 0.5 into 10 to the power of minus 4, which gives me the stress. And strain is nothing but change in length by original length, which is unknown. So the unknown quantity, which is nothing but change in length by original length, or the strain, is computed as 0.05 from the above expression. So now we know the change in length by original length and we know the delta R by R. So we can easily calculate gauge factor, which is nothing but delta change in resistance is 1 ohm when 50 kilonewton load is applied, and the original resistance is 100 ohms divided by change in length by original length, which we computed in step 1 as 0.005. When we simplify this expression, we get it as 2. So the gauge factor for this strain gauge is 2. So here the correct option is D.